Ernest Rutherford is a Nobel laureate and is known for his contributions to the field of atomic physics. He is particularly known for his pioneering work on the structure of the atom, which he proposed in the early 20th century. Rutherford's atomic model was based on his gold foil experiment, which he conducted in 1911. In this experiment, Rutherford bombarded a thin sheet of gold with alpha particles, positively charged particles, and observed the scattering of these particles as they passed through the gold foil. Based on the results of this experiment, Rutherford proposed that the atom is composed of a small, dense, positively charged nucleus at its center, surrounded by a cloud of negatively charged electrons. This model was a significant departure from the previous understanding of the atom, which was based on the plum pudding model proposed by J.J. Thomson. According to the plum pudding model, the atom was a uniform sphere of positive charge with electrons embedded within it. Rutherford's model explained several observations that could not be accounted for by the plum pudding model. For example, the plum pudding model could not explain the scattering of alpha particles in the gold foil experiment. In contrast, Rutherford's model correctly predicted that the alpha particles would be deflected by the positively charged nucleus, as they are repelled by like charges. Rutherford's model also explained the stability of the atom. According to classical electromagnetism, the electrons in the atom should be attracted to the nucleus and should eventually spiral into it, causing the atom to collapse. However, this does not happen in reality. Rutherford's model explained this stability by proposing that the electrons in the atom are held in place by their own electrostatic repulsion. In other words, the electrons are held in place because they are constantly pushing against each other, preventing them from collapsing into the nucleus. Rutherford's model also explained the phenomenon of radioactivity, which was discovered around the same time as the gold foil experiment. Radioactivity is the emission of particles or energy from the nucleus of an atom. Rutherford's model explained this emission by proposing that the nucleus is not completely stable and can spontaneously decay, emitting particles or energy in the process. While Rutherford's model was a major advancement in our understanding of the atom, it was not without its limitations. One of the main limitations of the model was that it could not explain the observed spectral lines in atoms. Spectral lines are the characteristic wavelengths of light emitted or absorbed by atoms, and their observed patterns provided important clues about the structure of the atom. It was later discovered that these spectral lines could be explained by the quantization of energy levels in atoms, which was proposed by Niels Bohr in 1913. Another limitation of Rutherford's model was that it could not explain the observed size of atoms. According to classical electromagnetism, the size of the atom should be proportional to the size of the nucleus, but this was not the case. It was later discovered that the size of the atom was determined by the size of the electron cloud, which was explained by the wave-like properties of electrons. Despite these limitations, Rutherford's atomic model was a major milestone in our understanding of the atom and laid the foundation for the development of modern atomic theory. It is still taught in introductory physics courses as a starting point for understanding the structure of the atom and serves as a historical reference for the development of atomic theory.